river in still water. Okay. Whenever there is a velocity of a boat in still water, that is nothing but velocity of the boat with respect to river. So if we, so let us say you are moving on a ground, you are moving. What we can say, that is a velocity of a person with respect to earth. Okay. And so if we are moving on a water, that is the velocity of a person with respect to water flow. Right. And W is the width of the river. Let us consider. Right. Now let's see this thing here. Let's understand. In the one by one case, listen carefully. Case one, we'll talk about the downstream. Downstream means if we are moving along the direction of river flow, river is flowing okay in x direction, you are also moving x direction only, then you are, that is called as the downflow, the downstream we can say. Okay, so means, so let us consider this is the river, and so let us say this total, the distance of this river, length of the river is something d. Now let us consider the river is flowing like this with a velocity of vr. Next, the boat we are talking of, the same place, in place of boat we can place swimmer, we can place. And velocity of a boat is also try to move eh, in the same direction, velocity of boat with respect to river, vbr. Now both are same direction only now, then this type of motion is called as a downstream we can say. So now look at now basically what we can say now here, VBR, that is a velocity of boat with respect to river now, and that we can write it as what, tell me now, VB minus VR. Now so that means from this we need to get the VB value. VB is equal to what, you tell me now, that is VBR plus VR. Now look at now here, from this we can say now VB value we need to get. So look at now, VBR is along positive x direction. We are also positive x direction only. Then what we can do, we can add them directly. So that means what will get, you tell me now, this is VBR plus VR. This thing you understood? So that means now obviously you just imagine now the velocity of a boat. So here the boat is moving this direction. Boat is moving x direction. So river is also moving same direction. What is the actual velocity of a boat, you tell me now? Will increase or decrease? River is moving this direction. Okay. And boat is also moving same direction. Increase now. So that's why the your boat velocity will becomes what, tell me now here. So actual velocity of a boat plus river velocity also. That's why will be added. Okay, that is the downstream. So that means now this is the downstream flow. From this, let us say here, can you able to find the how much the time taken by the boat to travel from travel distance of d? We can find the time taken, we can find now. Yes, tell me now, time taken. Time taken by the boat. The time t, which will be time is equal to what, I know, basically distance by Speed. That is speed of the boat, na? And so, so how much time will take to travel from starting to ending? Ending of the river. So let us say length of the river is something D we have considered. So that T is equal to what, tell me now? D by what will get to, tell me now? That is VBR plus VR. Right. So that means the boat is moving along the river. So that's why boat velocity, river velocity will be added. This is what we can say downstream, along same direction. Right. Done. Next, now let's talk upstream. Upstream means what? Tell me now. Yes, the boat is moving against to the river flow. Now, this is the river velocity VR and the boat velocity VBR. Sorry, we will take opposite direction now. Let us say river is flowing this direction. We need to move upward. Okay. Now you tell me in this case, same as earlier. So what is the VB now? We have seen now that is equal to we have seen now VBR plus VR. But here these two, how these two are now? One is positive x direction and VR is negative x direction. Now we have to subtract them. So any confusion? If you have confusion, then we can start with the vectors we can do. Okay. So look at now how we'll write now VR is a vectors. If you have a confusion, you can start with the vectors. How we can write now this is negative x direction now? That is minus VR into I cap. Next, what is the VBR you tell me now? And which will be equal to VBR into I cap. So what we need now here, this is VBR means what, tell me now? That is VB minus VR now. Now we need to get what, tell me now? VB we need to get. That is what, tell me now? VBR plus VR. Now you tell me now how much is VB equal to. So VBR, so that is VBR into I cap. VR means minus VR into I cap. Okay, if you have a confusion, you can do by vectors. So that is VB, which I can write it as what, will be now? This is VBR minus VR into I cap. From this we can find the magnitude of VB, which will be equal to what, will be now? VBR minus VR. Okay. Now from this we can get the time now. And with the time taken to travel d distance now, that is d by VB. So this time t is equal to what we can say now here, d by. So that is VBR minus VR. VB. So obviously you can see now here. So you are moving against to the river flow. That means what, tell me now? The river will try to oppose now. You want to move like this, but river is moving like this. Then what happened to actual velocity? With what velocity the boat will move now here? So boat velocity minus river velocity. Upstream we have, that's why VBR minus VR. Understood? This is in case of a upstream. In case of downstream, plus. Right. Then next. Now let's see this thing here. Time taken by the boat to travel a distance d in the downstream as well as upstream. It is moving there and again come back. Uh, uh, Simply anything is possible. So just we need to consider only, na? Here no need to do physically, right? So that means now you can see now here, let us say here, now this river is flowing like this. This is the velocity of a river. And this is the velocity of a boat with respect to river. And the distance is d. Okay. Now, so in this case, what happening now here? The boat, so which is now initially started at point A and this is reaches to point B. Now, so this means A to B motion. What we can say this upstream or downstream? A to B motion, upstream or downstream? So along the river flow now that is a downstream. Again, after reaching the point B, again will be moving back to B to A again. Then that is an upstream, right? So that means the total time taken we need to calculate. And the total time, so which will be given as what I can say now, this is a time taken for the downstream, okay, plus time taken for the upstream. Now tell me now here, time taken for the downstream is how much we can say now. Just now we have seen d by, what tell me? VBR plus VR na. And upstream case, what tell me now here? D by, that is VBR minus VR. Upstream case we have to subtract na. Downstream case we added. Then this is the upstream and downstream. Next we see the another case now. Till now we have seen the along the length the boat is traveling. Now we need to see this thing. Now the boat want to cross the river. Means this side to that side want to cross. That we are going to analyze now. Now look at now. Yes, now here, but in this case the river river is moving from here to A to B. It is moving here, crossing the river. This we need. In this we are now going to analyze now. So look at now. So take this thing here, general approach. Same the terminologies, entire case, remember. Yes, look at now. VR is the velocity of river with respect to ground. VBR is a velocity of boat in still water. Look at now what we can do. Yes, same thing here. So now in this case, the person want to cross a river. So you need to listen carefully. Very, very important topic. Now here, this is the A. Now this person want to reach the other side of the bank. Point B is exactly opposite to A. Now look at now here. So here the river is flowing like this. This is the velocity of river. Now let us say here how the person has to started. We need to see here. Yes, let us consider this person A started here. How the children? Now, if the river flow like this, then it is uh, thing like that. Now, look at now. So here, see this thing here. This is VBR. What is the VBR? Is a velocity of boat with respect to river. Okay, this thing VBR. Now, so this boat is try to move like this. Visualize. Listen, all of you once. The boat is try to move like this. Now, river is what? Tell me now here. The river is moving the right side. Now, the river will pushes the boat to the right side part. Yes or no? And the river, so this means because of this pushing, the boat, it is trying to move like this. The boat maybe go along this path, maybe along this path, maybe along this path also. Yes or no? So here the person want to move like this, but the river pushes the person to some other directions. Okay, he will reach the opposite bank, he will reach. The person may not be reach exactly the point B. He may reach at this point, somewhere. He may reach point B also. That depends upon the special case. Okay. Now we are going to say some general approach. We are going to do it now here. So that why we call it a general approach. Let's understand here carefully. Now, so this A and B are opposite banks. Now let us say the board started like this. Now let us say this board which is make some angle of something theta with a normal. AB line is called as what? Tell me now. Normal. Now what I do here, we resolve into components now here. This is. Now what we can say this component now, tell me now. This is VBR sin or cos. This is VBR into what? Tell me now, cos theta. And this is what? Tell me now, this direction now. This is what? Tell me now, VBR into sin theta. Is this point clear to all of you? VBR into sin theta. Okay, these directions. Okay, now look at now. Now here, so width of the river. Let us consider the width of the river. We have assuming this as something W. Width of the river is W. Now, so this person want to move from A to B. A to B. So that means what? I mean now A to B is along which direction we have? X or Y direction? Y direction. So that means now Y direction velocity only makes Y direction motion. Keep in mind. Only Y direction velocities only makes the body to move in Y direction. X direction velocities will makes the body to move X directions. Here, which is the Y direction velocity? How much the Y direction velocity we have? See that one. BBR cos theta. So not BBR. BBR is this direction. But only VBR cos theta is along the Y direction. Only this velocity only makes the boat to cross to move in the Y directions. Okay. Now from this, can I find the time taken to cross the river? Time is equal to what? Tell me now. This width by velocity of a boat now. Come on, the velocity of boat it is along the y direction. Width is y direction. So this velocity also y direction only. Tell me now y direction velocity. That is VBR into cos theta. This is a time taken. And in this time, because of the river, so look at now here, this VBR sine theta, because this velocity, so try to move this direction. But the VR is there na. This VR here means here only na. This VR pushes the boat to the right side. So here, what the VBR is, which direction? Negative x direction. VR is which direction? VR. Velocity of river is which direction? So that means what, tell me now? VBR sine theta. So because of this velocity, the boat tries to move the negative x direction. But VR, velocity of river, pushes the boat to move in the positive x direction. Okay, and with the net velocity now, tell me in along x direction. For the net velocity, if it is equal 0, may not be equal also, na? Who said equal? May not be equal. What is the net velocity along x direction? Tell me now here. We can say this as VR minus what? Tell me now. VBR sine theta. This is the net velocity along x direction. Isn't it? So this is the velocity along the x direction. Now, because of this velocity, what happens to the boat now will move along x directions. Okay, and the distance moved by the body along x direction, that is called as a drift. That is called as what? Tell me now. Drift we used to call. The distance covered by the boat along x direction is called as a drift. The drift is equal to what? Tell me now. X direction velocity into time. Distance. Distance traveled by the body along x direction. So, okay, drift we used to call, yes. Extra distance. That means what I mean, actually the person want to A to B want to reach. Now here, see this thing here, the boat may not be reach exactly the point B, na? So the boat may be reach here, maybe reach to here. Some other locations also may be possible or not. So this extra distance is there now. This distance is called as a drift. So here the person want to cross exactly opposite bank. But the person reached to some other location na. The distance is there na. So this B to C distance or B to D distance, this distance is called as a drift we can say. X will denote. X direction displacement na, X we can denote. So tell me now how much will be the drift now here? Vx. Vx is equal to how much now? VR minus VBR sine theta into T. T will calculate here, will calculate, and that T we can substitute here. Drift as well as time also. Okay. They will ask anything maybe unknown. So look at now here, that drift. So you may see this thing here, where the person will reach now. Either the person reaches to the CBD, which point the person where the person can reach any point. That depends upon the net velocity. Vx may depend करेगा. Look at now here. If the Vx is so here, look at now here. VBR sin theta greater than VR, then what happens? If VBR sin theta is greater than VR, so where the point the will reach now? Left side of B or right side of B? Left side of B. Sir, no. VBR sin theta is more now. If the VBR sin theta greater than VR, VBR sin theta is less than VR at the D point. If it is equal, ah, so this velocity makes the body to move which direction? Which direction? Velocity is one direction, yeah. So if this velocity makes the boat to move which direction? Positive x and negative x. So this velocity, so if we have velocity x direction, the person will move x direction. With the velocity negative x direction, person will move negative x direction. So here, now this VBR sin theta, because of VBR sin theta, boat will move which direction? Negative x direction. Because of VR, boat will move which direction? Now you tell me now here, VBR sin theta is more compared to VR. Then what happens? If this fellow is more compared to VR, then the boat reaches to the left side of B will reach. Okay. And if the VBR sin theta is less than VR, then where the boat will reach? The right side. This velocity VR is more now. So that means the river pushes the boat to D. If it is equal, then the person will exactly reach to the point B. Understood what I'm saying? Right. Copied now? Yeah, see this thing. That's what we can say. Conclusion, take it note as a take down. So we have taken. So this means what? Tell me now here. This is VR greater than VBR sin theta only na. In this case, the VR greater, which direction? Right side or left side? Right side, right of B. Then now in this now we have two special cases are there. So the two special cases we are going to see now here. Yes, look at now here. The two special cases. One is a shortest to time, shortest path. Let us say shortest time they are asking. Means what, tell me now? Shortest time means with a minimum time the person has to cross the river. Minimum time the person has to cross the river. For that purpose, in that case, how the person has to start his journey? Yes, now here for the shortest time means what, tell me now? He has started at the point A. Now he has started journey. How he start? You tell me now here. So his complete velocity he will point along the opposite, along the normal he has to start. Okay, that means complete velocity is this direction if we direct. Then he will reaches to some other location. Not point B he won't reach. He will reach the point D, but he will reach in the shortest time he will reach. Okay. So that case we are going to analyze now. Look at now. In shortest time. So here to cross the river in shortest time, what has to be done here? The boat is rowed normal to the bank. Okay, that means he started journey perpendicular to the river. He started journey like this now here. So here this A and this is the B. How the person started his journey, tell me now. In this case, his journey he has to start from like this. Right. So this means his velocity is like this. This is the velocity of a boat with respect to river. If we start, but what the river pushes this boat to some other, river pushes this fellow to this direction. This is the velocity of a river. Then as a result, the person will reaches where the person will reach now here at this location he will reach. So let us say this point I'm calling it as something C we call it. Right. Now this is a triangular law. So here VBR, VR. Then this velocity is called as what element of VB we can say now. This velocity is VB. Now look at now here. This VB, if we observe carefully, that is nothing but hypotenuse of this two now. VB is nothing but hypotenuse of this triangular, not. So can you tell me now how much this VB value? That is square root of what, tell me now? Yes, VB r square plus VR square. Okay. This is the VB. Now you tell me now here time taken to cross the river. You tell me now here two velocities. One velocity is a VBR, other velocity is VR. VBR makes the boat to cross. VR makes the boat to move from B to C. Okay, now we want the time I need now here. Let us say width of the river is something W. Tell me now time to cross the river. So that is W by what, tell me now? VBR. VBR only. Well, which direction? Only along Y direction na. Y direction, which velocity is there? Only VBR is there. That velocity only. So that velocity only makes the boat to cross a river. Okay, X direction velocity causes X direction motion only. Y direction velocity causes Y direction motion only. Okay, so VBR is along which direction? Y direction. So only that velocity makes the boat to move from A to B. Okay, A to B. How much the distance of A to B is there? Distance is how much? W. Oh, velocity. VBR. That is distance by velocity. Next. Now what the drift now? Yes, drift B to C now. So drift is caused by which velocity? Drift is caused by which velocity? That's why. So this means, yes, which is equal to what? Tell me now. VR into T. Understood? So this is the condition for the shortest time. Remember this point here. If we want to reach the other side, the shortest time, how we start now? He has to move perpendicular to the river. He has to move perpendicular to the river. He has to move. Keep in mind. Then now next case we'll see the shortest path. Shortest path means what? Exactly opposite bank has to reach. That means the person has to reach from A to B only. Exactly point B only has to reach. That means exactly point B reach means how much the drift? Drift must be zero. We should not have any drift na. Drift means what? Tell me now. Extra distance B to C, B to D distance na. We should not have this distance should not be. Yeah, so that means that we need to focus now. Yeah, you just tell me now here in this case. So here in the shortest path के लिए how we start his journey? Tell me now. So for the shortest path के लिए how we start his journey? A and this is B. Look at now here. And the river is flowing like this, let us say. Then tell me now how we start the journey? Tell me now. Let us say if the person started the journey here like this, then what happens now? This is VBR started and this river pushes him like this. Then as a result, this person reaches somewhere here, na? In the drifted non-zero here. Okay, that means how the person has to start a journey, tell me. Now, if the person started journey like this, let us say, and this river pushes him to this here, exactly this line, then the person exactly reach the point B. Understand what I'm saying here? This is not midpoint, yeah. So this arrow means here also. Okay. So this is the velocity here. This velocity there, here, everywhere is there, na? Okay, here everywhere is a river only, isn't it? And this is what tell me now VBR. He started journey with some angle, some left side he started, and then VR pushes him along the AB line. Okay, understood the situation. Now here the person started, he want to move to A to B. The person started a journey like this. Just imagine now here, started like this, but the river pushes him like this now. Then this boat will move like this only na. The pushing of the river is here, is there, here, everywhere is there na. So the boat will keep on, will move in this path only na. In that case, drift is zero. Yes, in this case, the person is reaching the opposite point na. Drift is zero only in that case. Isn't it? Yeah. Now tell me now here. So then in this case, if this is VBR, this is VR, then this must be a VB now. Now tell me now the relation between these three velocities now here. Now which is the hypotenuse now here? VBR is hypotenuse now here. So can you tell me now VB now in this case? That is square root of what? Tell me now. VBR square minus VR square. Now here this angle, if I say this is theta. Now from this, can you tell me now sine theta? Yes, so what should be now sine theta from this now here, which is equal to VR by VBR. This is the relation between the velocities in case of what? Tell me. Yeah, shortest path. Yes. In this case, drift is equal. Hmm. Then there are six cases. Understood now all these cases? So here, so you need to revise one, then it will be easy. Right. Now let's see the problems on this. These problems are very important. Yeah, take this one. Hmm? Yeah, handwritten format. Uh, Pretty available now. The next topic will start the Newton's laws. Next chapter. In the what we can say, generally physics, each chapter will contain number of topics. We'll simply call it topics, we'll say, instead of saying the chapters. And the Newton's laws also will contain so 7, 8 topics are there. Chapters are big only. So in ninth class you studied Newton's laws, not studied. Uh, those only. Right. First law, second law, third law. Statement. So here you'll see this thing. Numerical analysis we'll see. Hmm. Right. Listen here first. A boat takes 4 hours in upstream and 2 hours in downstream. Yeah, covering the same distance. Then they ask him to find what will be now the ratio of velocity of boat to the, that means velocity of river. They ask him to find what will be now VBR by VR. They ask him to find. Yes, we know that. So tell me now, upstream case, what is the formula? Tell me now. So upstream, TUP if I say, which will be equal to T by. So that is VBR plus or minus upstream. Minus. Upstream is opposite na. Next, this time they given us how much now? 4 hours given now. Next, downstream, and which will be equal to what terminal d by downstream VBR plus VR. How much this value? 2. Take the ratio between these two and simplify it. Hmm. You take the ratio between these two equations and simplify. Hmm. If we take the ratio now, d will get cancelled now. So will come it as what will be now VBR plus VR by VBR minus VR, which is equal to 4 by 2 now. That means which is equal to 2 by 1. Component of dividend? No component dividend, you know or not? You don't know. Now if you know, apply this thing. Component of dividend, so means if we have x by y, which is equal to a by b. No, so a component of dividend means what we should do here. Numerator we are doing x plus y by x minus y. Now what I did now here, left side numerator plus denominator I added. Same thing I should do right side also. Numerator plus b. A plus b by, that's it. Whenever we have this type of relations, this is helpful. Componendo dividendo will helpful. Componendo dividendo. And mass will know. So what tell me now? So both will be added. So first what I should do, numerator VBR plus VR plus VBR minus VR by. So next what we should denominator VBR plus VR minus, we are subtracting the denominator, that is VBR minus or minus plus na, that is VR. Same thing we should do right side also. Yes, 2 plus 1 by 2 minus 1. So then what will get now here? Here VR will get cancelled na. The denominator VBR will get cancelled. So what will get now? 2 VBR by 2 VR. 2 cancel. Yes, so now VBR by VR will come it as what, tell me now? Yes, 3 by 1. Yes, that's it. Hmm. Take the next one. Yeah, tell me now. Width of the river is how much? Yeah, so the same thing. Here you need to remember the things now here. X direction velocity makes only X direction motion. Y direction velocity is only Y direction motion only, keep in mind. Hmm. Yeah, distance we need to find, yeah. So here the width of the river is given as 2 root 3 kilometers is given. Fine. Next, a boat is rowed in a direction perpendicular to banks of river. Means what? Yes, A to B normally started. Yes. And velocity given? Not given. So here this the boat is moving straight away like this, try to move like this. This is called as what I mean VBR na? Next, if the drift of the boat is given, drift. So drift means the river is moving like this. This is the velocity of river na? And so because of that, the boat will move like this na? Because of the VR. Now you tell me now, they give a drift is given this much na? So let us just see, this they given as a 2 kilometers. Now you tell me now, yes, now which velocity caused the drift? Huh? VR. So it means drift equal to what we can say, drift x is equal to what I can say now, VR into T na? Ah, that only, step by step we are doing. So here x is equal to VR into T na? How much the displacement drift is given now? 2 is given. And VR we know. VR also we don't know. So fine. So this is VR into time also we don't know now. Now from this can I able to get the time taken to cross it? Can you get this thing here time taken to cross now here? Ah, yes, this time t is equal to width means how much here? 2 root 3 by VBR. VBR given. No, VBR not given na. Where is VBR here? VBR we don't know na. Okay, so here what we know here, you see this thing here. What we know here, this distance we know. Yes, now this distance A. So now A to B distance we know. B to C distance we know. Can I get the A to C distance? How much A to C distance? So this means A to C. So they are asking to find the displacement of a boat only they are asking to find. Here then we don't want the time also, na? Actually, here we don't want the time. Yes, now they are asking to find the distance only they are asking, na? That is AC. We need to get what I will now AC square, which is equal to what I can say simply AB square plus BC square simply, isn't it? So tell me now AC value, that is the distance traveled na, that is square root of AB square. AB value 2 root 3 whole square. BC value how much now? 2 square. Yeah, simplify how much now? This is 12 plus 4, 16, which will be equal to 4 kilometers. Okay, that's good. Okay, fine. That's it.